Okay, so now you've had a minute to look at all of the possibilities. Well, let's talk about what some of them are. So cosine of x equals 1/2. Where is cosine positive? Cosine is positive in the first quadrant and the fourth quadrant. And where is it 1/2? Well, it's 1/2 at 60 degrees and 300 degrees. But that says all of the possibilities. So it's also, if we go around go around the circle another 360 degrees, so not only is it 60 degrees, but it is also 360 plus 60, which would be 420 degrees. Okay. And we could go around again. So it's 420 plus 360, which would be 780 degrees. And it would just keep going. Same thing here with the 300 degrees. Okay. If we add 360 to that, if we go here, and we say from here, and we go around the circle one more time, it's 300 degrees plus 360, which is 660 degrees. If we go around again, it's 660 plus 360, which I believe is 1020 degrees. So the same thing is true over here for the tangent of x equals -1. What quadrant are we in? Well, we're either in the second or the fourth quadrant. We're either at the 3 pi over 4 or 135 degrees, or the 7 pi over 4, which is 315 degrees. But we can also go around the circle another time. So I can go from here and add 360 to 135. So 360 plus 135 would be 495 degrees. And I can keep going. And so when we're asking for all the possibilities, we need to think about that. Now for sine, we've got all of the possibilities here. We've got both positive and negative. Okay. So we have our first quadrant angle, we have our second quadrant angle, we have our third quadrant angle, and we have our fourth quadrant angle. This would be 60 degrees. This would be 120. This would be 240. And this would be 300 degrees. But again, we could go around the circle, add 360 to that. So that would be 420 degrees. Add 360 to that. This would be 480 degrees. Add 360 to that, that would be 500 degrees. Add 360 to that, that would be 660 degrees. And we'll just keep going. Now we don't want to just keep going. So in our examples, what we're going to see is we're going to see that we're going to restrict the interval so that we don't have to keep going and going and going. Because we could also go the opposite direction and say this is negative 60 degrees. That could be negative 60 degrees, negative 120, negative 240. Negative 300, and so on. So let's look at the first example. And we have this equation, 2 sine theta plus the square root of 3 equals 0. So we want to get the sine theta by itself. Let me try that again. We want to get sine of theta by itself. So the first thing I'm going to do is I'm going to subtract the square root of 3. And I get 2 sine theta equals negative square root of 3. Then I'm going to divide both sides by 2. So I get the sine of theta equals a negative square root of 3 over 2. And theta has to be between 0 and 2 pi. So where is sine of theta negative? Well, sine of theta is negative in the third and the fourth quadrant. So we can take either one of those two angles. If we think about it, 240 degrees, because it's the same as our 60-degree reference angle, or 300 degrees, also gives us a negative. So what are our values? And since this has, in terms of pi, that's really what we want to write. So theta, we said, is 240 degrees, or 300 degrees. But if we're writing in terms of pi, This is 4 pi over 3, and this is 5 pi over 3. If you plug either one of those two angles back into this equation, then you will get equal to 0 if you plug 4 pi over 3 in, if you plug 5 pi over 3 in. Check that on your calculator just to make sure. All right, let's look at the next example. This one, sine of 2 theta is equal to 1/2. So where is sine positive? Well, sine is positive in the first and the second quadrant. Where is sine of theta 1/2? Well, if we have 30 degrees, which is pi over 6, or if we have 150 degrees, which is 5 pi over 6. But notice, this says 2 theta, and this is where it gets tricky. So 2 theta can be 30 degrees, or 2 theta can be 150 degrees. Well, if 2 theta is 30 degrees, theta is 15 degrees. Check it. Plug it back in. 2 times 15 is 30. Is the sine of 30 degrees 1/2? Yes. So that is one of our choices. Same thing here. Solve for theta. We get theta equals 75 degrees. We'll plug it back in. 2 times 75 degrees is the sine of 150. Is the sine of 50 1/2? Yes. So that works. Now, I made this little note up here. It says make sure to check the interval. Well, if you're checking the interval, theta of 15 degrees and theta of 75 degrees are both within that interval. They're both less than 2 pi. But let's think about what would happen if we traveled around the circle again and landed here. Where would we be? We'd be at 360 plus 30. So we'd be at 390 degrees, which would be 13 pi over 6. Okay. Well, let's set this up. Let's check it and see. Okay. 2 theta would be 390 degrees. Solve that. Divide both sides by 2. And theta is 3. Let's see, that would be 195 degrees, I believe. Okay, well, if we can go around the circle here, we can do the same thing here. So if we start at 150 and go all the way around the circle and get back to there, the sine is still 1/2. So sine is 1/2. 150 plus 360 is 510. Okay. Divide both sides by 2, and you get that theta is 255 degrees. Is that still within our interval? Yes, because theta is still less than 2 pi, because this 2 pi is the same thing as 360 degrees. Okay, so could we go around the circle one more time? So we have this as an answer, and we have this as an answer. Let's try going around the circle another time. So at 390, I go around the circle one more time, and I have 390 plus 30, or excuse me, 390 plus 360. Which would say 2 theta would be 750 degrees. If I divide both sides by 2, I get theta equals 750 degrees divided by 2 would be 375 degrees. Now, is that still in our interval? No, it's bigger than the 360, so we're done. We have to be careful to say that ththese keep going, to realize that they keep going around and around and around, possibly, especially when we have a 2 theta or a half theta. We've really got to watch for that. So be careful of that. All right, let's look at one more example. Tangent of theta minus pi over 2 equals 1. Okay? So where is tangent equal to 1? Tangent is equal to 1 when theta is pi over 4. So whatever this angle is, has to be equal to pi over 4. Where else is tangent equal to 1? So we've got it here in the first quadrant, and we've got it here in the third quadrant. So at pi over 4, tangent is equal to 1, and at 5 pi over 4, tangent is equal to 1. Okay? But we want to know what theta is, and we have to subtract the pi over 2 first. So I'm going to solve this for theta. I'm going to add pi over 2 to both sides. And I get theta equals, if you need to, make these as common denominators. So this would be pi over 4. And this would be 2 pi over 4. So if we put this in here, we get 3 pi over 4. We'll check. Theta minus pi over 2. So 3 pi over 4 minus pi over 2. 3/4 minus 1/2. Is that 1/4? Yes. And is the tangent of pi over 4 1? Yes. So this would be one of our choices. Don't forget we've got to check this one over here too. So theta, if this whole thing is 5 pi over 4, then the tangent of that will be 1. So again, solve for theta. Add pi over 2 to both sides. So we get theta equals, again, if you need to, make these as common denominators. So that's 5 pi over 4. And this is 2 pi over 4. So we get theta equals 7 pi over 4. Again, if you're not sure, check it. 7 pi over 4 minus pi over 2. That's 7/4 minus 1/2. Does that leave me with 5/4? Yes. Okay. Now, just like we saw from before, we need to check what happens if we go around the circle again. So pi over 4, we go around the circle one more time. And so we add 2 pi to that. If we add 2 pi to pi over 4, that would be 9 pi over 4. So theta minus pi over 2 is equal to 9 pi over 4. Again, solve for theta. This is 9 pi over 4 plus 2 pi over 4 is 11 pi over 4. Is that still in our interval? No, it's not still in our interval because 11 pi over 4, 11 divided by 4 is bigger than 2. It's almost 3, so that would not fit in our interval between 0 and 2 pi. So this one doesn't work. Okay. All right, so here's what I want you to try for the rest of class. These are the problems I want you working on. Go back and check the intervals. If you're not sure, go back and look at the examples on pages 226 to 228, looking at examples for examples 2, 3, and 4.